Okay, let's just take a few minutes to look at these two problems. These were the ones that caused the most headaches on the quiz, I would say. We are given some information here that WC bisects BWD. Okay, so based on that, we can make the conclusion that BWC and CWD are congruent. We are also told that WA is perpendicular to WD. Okay, so this whole thing all together, if they're perpendicular, it's a right angle. Therefore, if it's a right angle, it's 90 degrees. All right, so we're going to use those two pieces of information to write a system of equations. Again, note that when we have x's and y's, we're dealing with x's and y's. A little hint should go off in our head, a little light bulb should go off in our head that we're looking for a system of equations. Okay, so that first statement, WC bisects BWD, should lead us to the equation that states that the measure of angle 2 is equal to the measure of angle 3. So 3x plus y equals 2y minus 9. Okay, and a lot of you got this first one, and then you tried to work with just the one equation, but you need a second equation, and that's going to come right from that second piece of given information, that WA is perpendicular to WD. So again, if those two are perpendicular, we know this entire angle is equal to 90 degrees. So if we add all of these three angles up, we should get 90 degrees. Okay, so 6x plus 3x plus y plus 2y minus 9, that all equals 90. All right, now we're going to do some simplifying. I'm going to rewrite this equation. I'm going to bring the y's over to their left side. So 3x minus y equals negative 9. And this one I'm just going to simplify. 9x plus 3y equals 99. Notice I just swung this negative 9 over here, and I added it to both sides. Okay, and this system of equations, you could either substitute, or it sets up pretty nicely for elimination as well. So I'm going to multiply this top equation by 3, and then rewrite what I have. 9x minus 3y equals negative 27, and the other equation is 9x plus 3y equals 99. I'm going to add these equations together, which will eliminate the y's. 18x equals 72, so x equals 4. Right, and once I have x, I could substitute it back into one of my original equations to find y. So 3 times 4 minus y equals negative 9. 12 minus y equals negative 9. So negative y equals negative 21. Therefore, y is 21. Okay, so I have x is 4, I have y is 21, but the question is, does WB bisect AWC? Okay, so does WB bisect AWC? Well, let's see. If it does, then angle 1 and angle 2 should be congruent, of equal measure. So with x equaling 4, angle 1 is 24 degrees. And with x equaling 4 and y equaling 21, angle 2 is 3 times 4 is 12, plus 21 is 33 degrees. So no. WB does not bisect AWC because the measures are not equal, or the angles are not congruent. Okay, let's look at number 3. 3 had a bunch of given information as well that we needed to kind of figure out how to piece together and work with. So PA is perpendicular to PD. Okay, so there we've got a right angle there. We also know that PC is perpendicular to PG, so that's here. We know that PB bisects APC, So these two angles are congruent. And that PE and PF trisect GPD. So we have 1, 2, 3 congruent angles there. Okay, notice though that these angles are not necessarily congruent to these angles. We have nothing that says that. And then our final piece of information is that the measure of angle GPE, which is this whole angle, is 32 degrees. Okay, so that's actually where we're going to start with that 32 degrees. That's going to be helpful to us. Okay, because if GPE is 32 degrees and we know that these three angles are all of equal measure, right, that means GPE has actually been bisected as well. Right? So if the two of them together are 32, then one of them must be 16, and this is 16. And so is this, because those are three angles of equal measure, three congruent angles. Okay, so now here's where it gets a little tricky. So take a look here. We have this angle here makes up a portion of a right angle, right? Remember, this whole thing is a right angle. So we have this angle here makes up a portion of a right angle, in addition to this piece of the angle. So we can actually find the measure of angle CPD because we know that the whole angle is 90 degrees and we know that a portion of it is 16 times 3 or 48 degrees. So this angle here is really just 90 minus 48, which is 42 degrees. Okay. So now, remember that this is a right angle here, right? We've taken care of 42 degrees of that right angle, right? And we know that the rest of the right angle has actually been bisected. So we can figure out this entire angle is 90 minus 42, which is 48. And then each piece of it is 24 degrees. So the measure of angle APB is 24 degrees.